Hi friends, welcome back. Today we will see feature engineering on again our car MPG dataset. So hope you remember that we have done the same kind of work around during decision tree. So you can also check out the links and the playlist for the same, but this is the further and the complete analysis on the uh, car mpg, right? So we will use basically clustering and pca, and finally we will apply our feature engineering here. So before wasting our time, let's start with one by one. So again, first importing the library to enable plotting graphs in Jupyter notebook, then numerical libraries numpy and train test split for our a training and testing data set, importing that from model selection. Now importing linear regression, so again that is a machine learning library we will be using. K-means clustering from scalar.cluster to handle data in form of rows and columns, so import pandas as pd. Now importing plotting library, so matplotlib.pyplot as plt, importing seaborn for statistical plots. So we have read the csv, now checked off few records to get the feel of the data structure. So again getting the head of mpgdf, similarly describing, so it will again give the count, mean, standard deviation, minimum and interquartile ranges, right? Now here what we are doing is temp equals to pd.dataframe mpgdf.hp.str.isDigit. so we are checking whether if there are digit or not. So here you can see that we are getting hp for all these values. So if that is hp, right, so just give me that false, right? If digit found, then give me false. Now mpgdf equals to now we are replacing this question mark with np.none. so although we have done all these steps in that video of decision tree, right? So but again I'm just walking through you out. Now mpgdf hp equals to mpgdf for hp, so as type float 64, it will convert the data type of the hp. Now hp is nothing but our horsepower here. So numeric column equals to mpgdf dot drop, so car name access equals to 1. Copy the mpg column alone into the y data frame. So this is the dependent variable. So car names equals to pd dot data frame mpgdf again for car name. Now numeric column, so numeric columns dot apply lambda x dot fill na x dot median and access equals to 0. So mpgdf equals to number columns to and join car names, right? So recreating mpgdf by combining numerical columns with car names. So mpgdf dot info, so we are calling finally the info method here. Step 4, it is asking that let us do a pair plot analysis to visually check number of likely cluster. So this is done using scattered matrix function, which creates a dashboard reflecting useful information about the dimension. So the result can be stored as a png file and open that in say pin to get a larger view. So here we will get all these columns, right, from 0 to 9, from 0 to 9 minus 1. So mpgdf attribute, this is disparity function, disparity attribute basically. So here we are putting the values of mpgdf attribute disp divided by mpgdf attribute cyl. So sns.pairplot will be mpgdf attribute here. Now the diagonal kind will be kd, so to plot density curve instead of histogram we can use that. So here the histogram will be for each and every attribute here, for mpg, cyl, displot, hp, wt, acc, right, so on so forth. Next it is asking linear model built on original raw data. So basically we are importing z-score here from stats and then mpg origin columns, right, and accessing all these columns for all the rows and storing the values in mpgdf attribute. Then we are doing the z-score, right, we are applying mpgdf attribute, apply z-score here. So first thing mpgdf, so we are popping the origin and year columns from our mpgdf, right? So array will be here mpgdf attribute dot z dot values, X will be our array for all rows and from 1 to 4 column, right? This is for all rows and first 7 columns which are the attributes. Then similarly for Y, that is array of all rows and 0th column. So select all rows and the 8th column, which is the classification yes or no, basically containing that. So then again xtrain ytrain, we are doing the same thing that we have done earlier. From sklearn import svm, we are importing svr here, right? So clr.fit xtrain ytrain, so this will contain our sbr values. Now y prediction will be clr.predict for x test, and then we will move forward to plot our join plot. So importing sns here, style that is dark grid, you can see, and color code will be true here. Now with sns.exe style we have white, so here the white color field, and the join plot for x test, so for y test and y prediction, and kind is again regular, and color you can see is equal to formed as k. Similarly we do that for iteration 2. So if we compare that, so here the comparison will be here, right? Because we will achieve 89% on the test data. The low score is due to the large opened and apparent mix of Gaussian. So we can explore it further, the data for hidden clusters. So next step is itself is k-means clustering. So we are normally defining our k-means clustering here, doing all the required things to apply that. And if we get the clusters error and number of clusters, so you can see that we are getting 4 clusters and their respectively clusters errors. So if we do elbow plot in that, so here we are defining the size and doing the elbow plot for df.num cluster and cluster error. So this is the elbow error. So the elbow error basically confirms that our visual analysis that there are likely 3 or 4 good clusters. Now importing k-means and z-score from cluster and statistics respectively, and taking attribute of mpg df attribute from getting mpg and origin column, and similarly again applying z-score on the same. Now cluster equals to k-means and cluster equals to 3, random state we are passing 2354. So if we fit our cluster here, right, so it will be fit here, and prediction will be cluster.predict mpg df attribute z. So mpg df attribute z of group equals to prediction. So here we are creating a new column group which will hold the cluster id of each record. So mpg df attribute z copy, so df mpg df attribute z dot copy deep equals to true, creating a mirror copy for a later reuse instead of building repeatedly, right? So here we are defining centroid now. So cluster dot cluster centers, so this is our centroids here. Now centroid df, again getting that reading data frame for centroid column will be from list.mpg df attribute. So we are dividing all these centroids with our respectively attributes. So instead of interpreting the numerical values of the centroid, let us do a visual analysis by converting the centroids and the data in the cluster into box plot. So here we are doing the same thing with each and every column, right? We have also done the same in the last session. So here we have basically there are many outliers on each dimension indicated by the black circles, and spread of data on each dimension. So invited by the whiskers is long due to the outliers. So if the outliers are addressed, the cluster will be overlap less than right now, so except the year dimension which has no outlier. So identifying the and handling the outliers here. So first we will addressing outliers at group level. So here lazy to type long name, so remaining it to data. Remember data is not a copy of the data frame, right? So here you can see we are storing this into data. Now replacing all the getting the median and the standard deviation of every group, right? Group dot standard, and subtracting the median from every members of each group, right? So to take absolute values. So this will return the group from here, and finally we will have data corrected and concatenated data. So here we will apply box plot in our concatenated data. So if we check that, so this is the description and this is the box plot that we'll get. Now things to be note here is when we remove outlier and replace the median or mean, the distribution shape changes. So the standard deviation becomes lighter and tighter, creating new outliers. The new outliers would be much closer to the center than origin outlier, so we accept them without modifying them. Now let us analyze the MPG column versus other column group wise. So MPG versus HP, variable equals to HP with sns.exe, right? Style will be white, plot equals to sns.implot. So variable will be MPG, data concatenated data, you will be group. So here we will achieve that the LM plot with a different group, that is 0 1 2 respectively. Similarly, if we do that for LM plot again, this time we have white with MPG and data is equals to concatenated data, again u equals to group, but here the plot set y limit we are passing as -3 to 3, so we can get that into different shape. Similarly, we are getting for ACC, right? We have seen for this and this for ACC, then we are getting that for WT, right, for all the group 0 1 2, and this way you can distinguish all these attribute applying all the plotting. Now step 7 is to break clusters into separate data set and analyze individually. So obviously we are making 3 cluster here, 0 1 2, right, breaking them into smaller segment. Now let us look to larger peer panel. So we are changing the car type at this point to check how the model performs for each group, right? And then we are plotting the density curve instead of histogram here. So here we'll get all these density curve for them. Now if we check attribute dot shape, that is mpgdf, so we have 137 by 8 here, and now we are applying svm on that. So we are again doing the same method to import the svm as svr and initializing the svr here, right? So if we get the style as dark grid and color code will be true, so here we will have access style for that as well. Now step 8 is we have alternative clustering strategy by origin. Since each record belongs to one origin, the cluster based on origin can be obtained using group. So what we are doing is we are defining mpgdf attribute z dot box plot by origin. Layout is 2 of 4, figure size is 15 and 10. So here group ACC, COIL, DISP, right? Everything you can see here. Now let us analyze origin wise. So do the origin norms, natural groups. Looking at the country wise spread, maybe sub cluster that is within origin cluster, sub cluster will give better result. So variable because will be ACC here with sns.exe access style, that is white here. Plot will be sns.implot, variable mpg data equals to mpg df attribute view will be our origin, right? Now plot dot set, we have y limit for 0 to 50. So here you can see that we are origin again for 1 2 3, right? So if we talk about the observation, so origin based clustering is not clearly distinguishing the cluster on any dimension. So two groups of cars based on origin, so America and Europe plus Asia, is unlikely to give better result as they overlap on all the dimensions, right? Now instead of grouping into large and small cars may give better result here. So if we repeat the same step as 6 and 7, but this time for k equals to 4, so we are doing the same thing, but here we are defining k as 4 here, right? You can see that number of cluster. And if we do the same thing for different level, right? So this is the box plot for all that, and finally we are getting the same our LM plot, right? So this is for HP, this is for DISP, this is for WT, right? And similarly we are again dividing that into smaller segment, that we are this time defining 4 cluster, right? Again doing the large car peer plot. So here you can see all the peer wise selections, and then we are again applying svm into new model, right? And printing the joint plot. So again for the final, if we see the observation, so most of the attribute are now showing almost Gaussian distribution, right? Here you can see that, and here you can see that, and the interaction between dimension 2 is relatively more linear, but there is a lot of spread. So this you can check out. Now the 10th is k-means clustering is not helping at all. So now trying principal component analysis. So let's do with PCA. So PCA should be used when the relations are linear. Looking at the peer plot of CYL, year and origin are likely to be ineffective on this case. So let us remove them before doing the PCA. So apply PCA for each group of cars. So column to drop CYL, origin group ACC. Now car attribute is smaller dot drop. So column to drop access equals to 1, car mpg equals to np dot array, car attribute dot pop, we are doing f for mpg. So from sklearn dot decomposition import PCA. So if we import PCA from here, so cov matrix np dot cov, car attribute, right, raw variable equals to false, np dot line algorithm dot eiz cov matrix, eigen values, eigen vectors equals to np dot line alignment eiz cov matrix. So we are doing the same thing again, sorting the eigen values, eigen vectors pairs from lowest to highest with respect to eigen values. Now reverse this sorted pairs from increasing values of eigen values of lowest. Extract the descending ordered eigen values and eigen vectors. So if we check here, you can see now an array of variance explained by each eigenvector. So there will be 4 entries as there are 4 eigenvectors. So here we are doing an array of cumulative variance. So there will be 8 entries with 8th entry cumulative reaching almost 100%. So this way we are now printing our bar plot, right? And the step you can see here for cumulative explained variance, and this is for individual explained variance. Now transform the data into PC dimension. So again we are defining PC1, PC2 and MPG, right? And selecting XY for the PCA and for the MPG respectively. Now if we check the shape again, so we have this time 99 by 1. So let's again try to use SBM. So calling SBM, passing SVR, right? Defining it for X train, Y train. Now prediction for CLR dot predict, right, for X test. So importing Seaborn as SNS, right? Style equals to dark grid, color code will be true. With SNS dot access style white, right? SNS dot join plot. So X equals to Y test, Y equals to Y prediction, kind equals to registration, color will be K, right? So this the joint plot you can see. Finally we have also seen till here in the last video for the grid search, right? But now the main thing about this video starts from here, that is feature engineering, right? So let us group by car type. Large car we are segmenting as 0 and other will be 1. So creating a separate column in the CSV file will create where cars with 8 and 6 cylinders are large car, code is 0, and all other cars that will be with other cylinders, so number are grouped into other, so code will be 1 here. Now mpg df attribute, mpg df dot log, right? So here we are getting all the rows and mpg and car type columns. mpg df attribute applying z score here. Now mpg df attribute z dot box plot. So by car type layout equals to 2 and 4, figure size is 15 and 10. So again you can see for all those attribute, right, the box plot we are getting. Now large cars, that means higher horsepower, higher displacement, higher weight, seems to have a better inverse relation with the mileage the cars. So let us see if we can cluster on these dimensions. So mpg versus HP. So how we can get that? We are defining variable as MPG, variable as HP, and then MPG. So here you can see that, right? MPG and HP respectively. Similarly, MPG dot weight. So MPG dot weight. So here you can see the feature engineering, and MPG dot here you can see that lm plot, and mpg dot disp here, right? So this is for -1, this is for 0, so all these value you can get it. Now let us break the data into larger and smaller segment, of course. So larger indicate by 0 has become negative score, and other case indicated by 1 has become positive value. So let us look at larger pair panel. So this way we have larger car.ilog, right, for all rows 0 to 8th column, and sns.pairplot mpg-df attribute diagonal kind equals to kd to plot density curve instead of histogram, right? So here all you can see. Now array equals to mpg-df attribute dot value. X array will be for all rows 2 to 4 columns, select all rows and desired column. Y equals to array all rows and 0, select all rows and the 8th column, which is classification yes, no, and diabetes. Now x train x test, y train y test. Train test split will be xy, test size will be 0 point, that is 30%, and random state will be 1. Now from sklearn importing svm, so clr will be svm.svr, clr.fit x train and y train. So here again you can get that. Now y prediction, we are getting clr.predict x test, so sns.set styler, dark grid we have, color code we are passing true. Okay, now with sns.access style white, sns.join plot, so x equals to y test, y equals to y prediction, kind equals to reg, and color equals to k. So here all that you can see. Now trying PCA to improve performance, so calls dot drop cyl, origin accy, year, and car type, all that we have. Now car mpg np array, car attribute for pop, we are popping this mpg from here. So again importing the PCA here, right, from decomposition, importing PCA. So if we apply all these PCA for COV matrix and getting that np.cob car attribute and raw variable equals to false. Similarly, we are getting the eigen values and eigen vectors here from np.linear algorithm dot eigen, right, cov matrix. So all that you can see from this code. Now eigen pairs reverse, yeah, basically it will reverse this sorted pair from here and increasing value of eigen to lower, right? Now we are having total sum of eigen values in our total column, right? And here variable explained, so it will hold an array of variance explained by each eigen vectors, right? There will be 4 entries, as there are 4 eigen vectors that we have. Now an array of cumulative variance, so there will be likely 8 entries, with 8th entry cumulative reaching almost 100%, right? So if we get that array, so you can see that we are getting for 86%, 95%, and 100%. Now transforming the data into PC dimensions, so if we check with that, so car mpg equals to car mpg dot reshape, we are reshaping length of car mpg of 1, eigen space np dot array eigen vector, sorting 0 1, and then transpose project data 3d np dot car attribute eigen space, right? So here names pca1 mpg, all that we have. mpg pca array equals to np dot concatenate project data 3d car mpg access equals to 1. Now mpg pca df equals to pd dot data frame mpg pca array column equals to name. So x equals to mpg pca array, that is for all the rows, and column from 0, right? That means it will select only the PCAs, right? For this way it will select only for mpg column, as also suggested here. Now if we do train test split for our xy, test is 30%, remaining 70 is for train. Now from sklearn importing svm again, right, fitting the model on x train y train. So if we get the joint plot, so again you can see that the joint plot that we got after applying our feature engineering, right? So if we talk of their observation, so the mpg column for different brand name are suspected, so found values much larger than the factory values for those cars, right? So definition of mpg2 have to be looked at. Now the weight of the car too is suspected, as they differed from the specification from those model. There are different type of weights, was the data collected constantly. Now the HP column 2 had values different from the factory specification. There are different type of HP values was standard definition followed by. Now suggestion are here for those instances where the declared mpg is greater than factory mpg, right? Replaced with factory mpg. Similarly for other columns, when this was done, right, so the standard distribution for the mpg column fell by 50%. So yeah friend, this was all about the complete analysis on that our car mpg. So detailed video we have done, half of the detailed video we have done in the previous video for the car mpg dataset, right? But hope this also helped you to understand how we can apply the feature engineering here. So yeah, we'll come up with the next video very soon. Stay tuned. All the best. Thanks.